decimal left 2 spaces. Okay, and we drop the percentage sign. So when I look at 1.3%, I move the decimal place twice to the left, add the 0 wherever that extra hump is, and it is equal to 1.013. That would be our answer. So 1.3% or 1 3/10% is equal to 13 thousandths. Now for B, we'll do the same process. Okay, we start with 99.83%. We move the decimal twice to the left. We don't have to add any zeros to the left here, and we're going to say 0.9983 or 9,983 10,000ths. Now, some students ask me, or they notice that I put a 0 before the decimal point. The reason I do that is because it makes the decimal point stand out. We don't often see numbers that start with 0, right? So you know that there's a decimal point coming if you put the 0 in front. If I did, like, there's my little example of, I could do 0.17, well, that little period, that little dot can disappear. So if I put 0.17, it actually shows up better. Okay, that's the only reason I do it, is for clarity. Now the next piece that we're going to do is we're going to express a decimal as a percent. Okay, now this is important as well when we're going to communicate our answers. So I'm going to start with this 0.0652, which is also 652 10,000ths, and I'm going to move the decimal place twice to the right. So the decimal goes 2 spaces right. All right, now we're going to have to add the percentage sign here. So we're going to say this is equal to 6 52 hundredths or 6.52%. And B, 1.31. Now it's in decimal, we need to move it to the percent. The decimal goes twice to the right, and this is 131%. So we need to be confident in moving our numbers between decimal and percent. Okay. Now we're going to work on just some simple word problems that involve our percent. Now the first one is part is equal to percent times total. So when we look at percent of something, it's going to be a part of something, okay, and it's based out of 100. So given something is split into 100 pieces, how many pieces do you have, right? What's the percentage of pieces? So when we look at this, what number is 25% of 15? X is equal to that number. We've seen word problems similar to this before. So I know this is my is my equal sign. What number? That's my X. And it says 25% of 15. Now with of, that is multiplication. So it fits this model of part equals percent times total. So putting 25% into decimal form, which moves my decimal point 2 times to the left and drop in the equal or the percentage sign, we're going to say 25 hundredths times the total, which is 15. All right, I'm going to have to do some scratch paper, some long multiplication. By the way, you can use a very small, simple calculator for this first test. I didn't say that before, I'm saying it now. And here we have our 0.25. Okay, so I'm going to do some multiplication here. 5 times 15 is 75. 2 times 15 is 30. 375. But if I start with 2 decimals in the original multiplication, I have to have 2 decimals in my answer. So X is equal to 3.75, and we would say the number is 3 75 hundredths or 3.75. And that's reasonable. 25% should be 1/4 of 15. It should be smaller than a half. And it's just good to think of the number sense that we have with 25% of 15. It's a reasonable answer. It's a good answer. Moving on to number 4. Now we're adding on a little bit, okay? If 5 is increased to 8. The increase is, there's our equal sign, what percent, okay, the what part, what percent, that's going to be our x of the original number. All right, so as I'm reading it, I'm putting it into an equation. So the increase, now we went from 5 to 8. From 5 to 8, the increase was 8 minus 5. It's the number we had, right? Started, right? Ended with, minus the number where we started. So the increase is equal to 3. So the increase, 3, is equal to what percent, that's what we're trying to find, times the original number. And the original number that we have, we started with a 5. 5 is what we originally started with. So we can write this as 3 is equal to 5x. We divide both sides by 5 to clear the 5s. All right, 3 divided by 5, I'm going to have to do a little long division here. So 5 goes into 3 0 times, right? So I'm going to have to bring some decimals. Right now, 5 goes into 30 6 times. You finish it, notice it zeroes out. That's what we want. So we could say x is equal to 6/10. But the percent, it's saying what is the percent? The percent increase is 60%. All right, because 0.6 is equal to 60%. Okay. Any questions?
May you please show us the whole paper so we can take a picture, because when you write so fast.
I write too fast?
Yeah.
Okay. I will do my best.
It's okay because it's better we can take a picture. I'll come and view it later.
Well, I also upload the notes to D2L.
Yeah, I know, but it will, I mean, right after we finish the class.
Okay.
Yeah.
I will do my best, okay? Okay. And yes, it is test. I get a test. It is test 1 that is this Thursday.
Yeah,
The
I
video
have
is
a
not
question. The decimal spacing,
Yes.
like 1.3%. Sometimes people do it like times 10, so they can move the points.
Okay, it would actually be times 100. It would not be times 10. When you move, when you move a decimal,
so like when the number,
percent,
when the first number before the decimal is like 1 is big, like you have to add a 0 in front all the time. It should not be like more than 0, right?
Can you ask that question one more time? Oh, can't hear you.
Oh, I said that if you have a number like 1.3%, so when you are moving, you have to be going in your left hand, right? When the number is not 0 in front.
Right, correct. When you go to a percent from a decimal to a percent, or from a percent to a decimal, you move the decimal to the left 2 times.
Oh, okay.
Okay. It's always either twice to the left or twice to the right.
Okay.
Decimals, okay.
All right. I get it.
All right, let's continue with another word problem. Okay. So Andrea spends 20% of her monthly paycheck on rent each month. If her rent payment is $750, what is her monthly paycheck? So what are we looking for? That's the first thing, is we have to understand the problem. We are looking for X, the amount of her monthly paycheck. So Andrea's monthly paycheck. Okay, now I found that in that last part of the sentence. So we spend, or Andrea spends 20% of, there's our multiplication, her monthly paycheck, which is our X, on rent each month. Okay, and her rent on her rent is $750. So when I look at the whole, which is our rent, or the total, I'm going to take it times the percent, which is 0.20, multiplication right there. And in the end, I'm going to get her monthly paycheck, or sorry, her monthly rent, which is $750. Right, so I'm going to have to divide both sides by the decimal form, which is 0.20, 20 hundredths. You can drop the 0 and it's 2/10, but I have to do both sides. All right, so I'm going to take some scratch paper and I'm going to do some long division. So when I do a division problem and it involves a percent, a decimal, I have to get rid of the decimal because it's almost impossible to divide by decimals. It takes a lot of brain power. So I'm going to move the decimal to the right 2 times, both from the divisor and the dividend in the middle. Okay, so 20 goes into 75 3 times, and I do my multiplication. I get 150. 20 goes into 157 times. I do my multiplication. I subtract 140 because it's 7 times 20. I get 140 and I take down. So there's that first 0. Here's that last 0 before the decimal. Here's, I guess there's one more 0. So 20 goes into 105 times. Okay, subtract. I have a 0, but I have to bring this 0 down. And I completed my division, I'm sorry. So 750 divided by 20 hundredths is 3,750. So Andrea's monthly paycheck is, make sure you label it with the $ in front. It's the American system, right? It has to go in front. $3,750. $3,750. Now, the next example we have is solving discount and markup problems. And this example states, a surfboard, which originally was purchased for $400, so that's the original price, was sold on eBay at a discount of 40% of the original price. What the question wants us to find is, what were the discount, number 1, and the new price, number 2? Now, for either of these things we need to find, the first thing we have to find is the discount. So we will start with the original price. That would be the total or the whole, right, of 400. Oh, let me see here if I can erase. Set, there we go. Let me erase one of these zeros. Excuse me. We're going to take it times the percent of decrease, which is 40 hundredths. And we're going to get our value of the discount. All right, so the little scratch paper, 400 times 0.40. I have 1, 2, 3 zeros, and then 4 times 4 is 16. If I start with 2 decimals, I have to have 2 decimals in my answer. So I started with 2 decimals in my multiplication, 2 decimals in my answer. X is equal to $160. All right, so the discount is $160. Again, the $ goes in front, right? It's the American system, USD, $160. The new price is, okay, well, the new price, more scratch paper, 400, subtract 160, I get $240. So the new price is $240. So percent, we've looked at percent increase. We've looked at percent of our monthly paycheck. And this would be percent discount. Next is we're going to calculate the percent increase or decrease. So here we're going to have to find one additional number before we can put it into the equation. This example reads, if a number decreases from 200 to 120, find the percent of decrease, because it did decrease from 200 to 120. All right, well, I know that our decrease will be the original minus what it lowered to, what it decreased to. So our decrease is 80. So we want to find the percent of the decrease. So that means the original number times the percent decrease, because that's what we're finding is the percent decrease, is equal to our decrease of 80. So to solve for x, we will divide both sides by the original number. Notice that 200 cancels from both sides. I can also cancel, since both of these numbers end in a 0, I can cancel 1 0 from the end. So my scratch paper, I have 8 now divided by 20. 8 does not, or 20 does not go into 8. So I have to add that 0 in the decimal. 20 does go into 80 4 times. So x is equal to 4/10, but in percent, it would be 40%. So it was a 40% decrease. Okay, so we had to find out what the value was, how much it decreased first before we could put it into the equation. Any questions? Okay, then we're going to continue. We have 2 more examples. The tuition and fees cost of attending a public 4-year college rose from $4,020 in 1996 to $7,010 in 2011. That's over 15 years. Find the increase. I'm sorry, find the percent increase. Now, one thing it says is to round to the nearest 1/10 of a percent. So that's one place to the right of the decimal. Well, before we can do an equation to find the percent increase, we have to find the amount that it increased. So we're going to start with the amount, or the increase will be the current value, or the value in 2011, which is 7,610. And we're going to subtract from that 4,020. So the increase itself was 3,590. I'm checking my math to make sure everything is good. That looks good. So we want to find the percent increase. So we're going to take the original value, which is the total that we started with in 1996. We're going to multiply it times the percent. That's what we're trying to find. We want x is equal to the increase percent. And it is going to equal this increase. Okay, so if we wanted to find the percent increase, it's going to equal the amount of increase. So we're going to divide both sides by 4,020. Okay, the 4020s cancel off of the left. An X remains. And again, they both trail in a 0, so I can cancel those final zeros on the right. If there's 1 0 on the top, I can cancel 1 0 on the bottom as well. All right, so we have some scratch paper. It's a longer multiplication, but remember, we're gonna round it to the nearest tenth. So we only have to go to the hundredths place with our division. So we have 359 and we're dividing by 402. 402 does not go into 359 or it goes in there 0 times. I'm going to add a decimal, add a 0. So 402, just doing a good guess. I think 9 would be too much. 8 looks about right. And multiply 8 times 2 is 16, carry the 1. 8 times 0 is 0, 0, carry that 1 down, and then 32. So subtract 3,216 from 3,590. Get 374. And 402 goes into 374 9 times. We're going to do the multiplication. All right, now I could continue dividing with the decimal, but I don't need to because the instructions say to round to the nearest tenth. Now, so we would say 0.89, which is approximately 0.9. Oh, it says 0.1%. We need to continue. All right, let's continue. 402, so I'm going to erase a little here because we have a few more decimals. So if we bring down another 0, 10, 0 went there. 402 goes into 1,223 times. And it goes into, bring another 0 down right here. 402 goes into 140 0 times. All right, there's our 10. So 0.8930 is equal to 89.3%. Right, so I needed to read it a little closer. So the percent increase is, or was, 89.3%, which is a huge increase. Tuition almost doubled in 15 years. Last example for this section. Find the original price of a suit if the sale price is $46 after a 20% discount. So what we're trying to find is the original price. That would be the whole or the total. We know that the discount is 20%. So let's find out, what do I know about this? What do I know? I know that a sale price is the original price, subtract discount, gives me the sale price, right? That's what we've been doing. So the original price is what I want to find. That's my X. Now to get the discount, I have to do the percentage of discount, which is 20% times the original price, and I will get the sale price, which is $46. Now, I want you to notice what is happening here. We have a 1x subtract 2/10 of an x. I can combine those like terms to be 0.80 times x, which is equal to 46. Now, there is a wonderful math teacher that used to teach in our department. He's since retired. But he always talked to the students and said, if you if the sale price is 20% discount, that means you're paying 80%. And this is really what it shows that, because here's that 80% we're paying. So we're paying 80% of the original price is $46. So there's a couple of different ways that you can look at it. Now to solve, we are going to have to divide by this 0.80 or 80 hundredths. We're going to have to do some scratch paper and some long division. And I can just really divide by the 0.8. I can drop that 0 when I'm dividing. So I'm going to move the decimal point once. I'm going to add it. So now I'm dividing 460 by 8. So 8 goes into 46 5 times. Bring down the first 0, that the only 0 to the left of the decimal. 8 goes into 67 times. 7 times 8 is 56. All right, I'm gonna have to have 1 0. There's my decimal. I'm bringing it up. 8 goes into 45 times. And I zeros out. So X is equal to 57.5, or X was the original price. The original price was $57.50. Again, dollar sign in front of the money value, USD. All right, now, as I said, a lot of this, it's good to see and remember how the decimals are divided. Same with fractions. So that's why I keep it in this section. You do get to use a small calculator, not a graphing calculator, and you're not allowed to use your phone, but your phone will be busy with the Zoom anyway while you test. Okay. So, whoa, are there any questions? Not whoa, but are there any questions? Okay, well, let's go ahead and move on to section 2.7. And I think I have 4 different examples for 2.7. I'm looking at my notes. Yes. So this is another example or another section that is with word problems. Okay, so we're going to go on to 2.7 right now. Move it on. I have to go to the top here. Excuse me for scrolling. Right. Now, when you are working on word problems, remember the steps are to first understand that we need to know what we're looking for. Pictures are going to help a lot in this section. We're going to have to translate, which means to put the words or the story into a word problem. Into an equation. We'll solve the equation and then we'll answer in the sentence form, okay? And make sure it sounds reasonable or check. So the first example we have is a distance problem, okay, solving distance problems. So what do we know with distance? We know that distance equals rate times time. Distance equals rate times time. So the first example is a jet, it should be traveling, there should be a T in there, at 550 miles per hour, overtakes a small light plane traveling at 180 miles per hour. That had a 1 hour head start. How far from the starting point are the planes? All right, so what is happening is, here's the airport. We're going to say that this is the airport. And here, a small plane started flying. Okay, so here's my small plane. Maybe it has a prop on the front, okay? And they started out, and then in 1 hour, they looked out the window, and here was a jet. And I'm just gonna make it look like one of those fancy Batmobile jets. Fancy ones. But when it overtook it, what happens when it overtakes it is the distance is the same. Okay, so a great way to look at this is with these distance problems is often it's going to be the distance is the same, or you add the distance together to get a total distance. For this instance, the distance is the same. In fact, I'm going to say that the distance of the small plane equals the distance of the jet. All right, so for these word problems, it's nice to organize your information into a table because it's going to end up giving us information we can put into this equation. As an example, for the small plane, notice I have in the top row rate, that's the first or the second column. Time is the third column, and then it's going to equal distance. So with the small plane, the rate is 180 miles per hour. I'm just going to go ahead and erase this little bit of a plane so you can read it. 180 miles per hour. Now the t, well, a time, we don't know the time, so we're going to let t equal the time for the small plane. Okay. T is equal to time for the small plane. Now, what is the distance? Well, rate times time equals distance. So even though we don't know what the time is for the small plane, we don't know what the distance is, we can express it as a term, 180 t. Now let's talk about the jet. The jet's rate is 550 miles per hour. Now it traveled 1 hour more because it started 1 hour after the small plane. So since it traveled 1 hour more, it is going to be a t plus 1 hour longer. So we're going to have 550 when we put our distance in, and then in parentheses, the whole time, which is t plus 1. All right, so this top line right here, 180 t, is the distance of the small plane. This 550 times the quantity t plus 1 is the distance of the jet. We know that when the jet meets the plane, their distance is the same. So I'm going to write the distance of the small plane, 180 t, is equal to 550 times t plus 1. And then we solve. Let's move this up a little. All right, so first thing, I'm going to distribute the 550 to clear parentheses. I'm going to, let's see, how do I want to do this? I'm thinking here. Oh, I made an error. We're gonna have to correct something. Sorry. I want to look at the time right here. Can anybody tell me what is wrong with the time?
It was the plane going 180 that had the 1 hour head start.
Yes, because he traveled 1 hour longer. Darn it. Okay, so we're gonna have to change that. So let's go ahead and take a look. We're gonna change a few things. It's easier for me than for you, sorry. So let's go ahead back, and our time with the jet is t. And since the small plane had a 1 hour head start, t plus 1. Sorry, let's rewrite. I think that was Kelly, thank you. So we have 180 times t plus 1, because it traveled 1 hour longer, is equal to 550 times t. Okay, so now let's distribute. 180 t plus 180 is equal to 550 t, much better. Subtract 180 t from both sides. It cancels off the left. 550t minus 180t is 370t. We're going to do some division. Divide by 370. And I end up with t. I'm going to do a little, here we get the answer. T is equal to 0.486 hours. All right, well, now the reason I'm leaving it as the decimal is because we're not looking for the time. We're looking for how far from the starting point. So T represents the time for the jet. And I know that to find distance, it's 550 times T. So the distance that we have, we are going to take the time is equal to the 550 times 0.486. And we'll just go to the hundredths. So we'll say distance, we'll take 550, multiply it times 0.49. Bring down the zero, so a little bit of long multiplication. Two, 6, 5, 9, 0. But I had two decimals when I multiplied. It is time, or the distance is going to be equal to 269.5 miles, about 270 miles when the jet overtook the airplane. Sorry for that error. So the charts can help us organize the information, and we have to take good details as I showed in making sure we put our variables represented correctly. So let's try this next one. The first example we had right before I said that either the distances are going to be equal or you're going to add the distances to get a total distance. Those are two very common distance equals rate times time word problems. So for this next example, I want us to suppose two trains leave Jackson, Mississippi at the same time. One travels east and the other travels west at a speed that is 6 miles per hour slower. In 1/2 hour, the trains are 45 miles apart. Find the speed of each train. So what we're going to have, I'm going to draw a picture because this is going to be where they start. We have one train that is traveling east. I'm just going to let this look like a modern train. Yes. It's traveling east. And we know still the distance equals rate times time. But at the same time, we have another train. Okay, maybe it's an older train that is traveling west. And after 1/2 hour, the total distance is 45 miles apart. So they're traveling in distant or in opposite directions. So we are going to look at their total distance. So that means that the distance of the eastbound train plus the distance of the westbound train will equal a total of 45 miles apart. All right, so let's go ahead and look at how are we going to represent the distance of the east train, eastbound, and the distance of the westbound train. All right, so the rate of the slower train. Well, we don't know. So we're going to let the slower train, it says it's 6 miles per hour slower. So we're going to say that the faster train, the rate is R. So R equals the rate of the faster train. Now, if R equals the rate of the faster train, and the slower train goes 6 miles per hour slower, how do I represent the rate of the slower train? It's going to start with an R. It's going to end in a 6. Are we going to add the 6 or subtract the 6? It's a slower train, so we're going to subtract the 6. We're going to subtract the 6. Okay, so the time, 1/2 hour. It's written in, they both traveled at the same time. So with the slower train, we're going to have 1/2 times R minus 6. And with the faster train, we'll have 1/2 times R. And we know that after half an hour, they are 45 miles apart. So we're going to take the rate of the eastbound train, which is the faster train, 1/2 R, plus 1/2 times R minus 6 is equal to 45 miles apart. Now you can either choose to clear fractions, or since we're working with 1/2, they're kind of easy to work with. So in this case, I'm just going to leave the fractions. I'm going to choose to leave fractions this time and say 1/2 times R gives me 1/2 R. And then 1/2 times a minus 6, well, half of a minus 6 is minus 3. That wasn't too hard. I know 1/2 R plus 1/2 R gives me a total of R. I'm going to add 3 to both sides. And I find that R is equal to 51. I'm going to check. Oh, you know what I did? I wrote down the total here. So 45 plus 3, R is equal to 48. So that's the faster train. R then equal to minus 6 is equal to 42, and that is the slower train. To express my answer, I want us to find the rate of the train. The faster train rate is 48 miles per hour. Slower train's rate is 42 miles per hour. And this is a quick check. 1/2 hour, 48 miles per hour would go 24 miles. In 1/2 hour, 42 miles per hour would go 21. 24 plus 21 is 45 miles. That's exactly what they were supposed to be apart. Any questions?
Yeah, I have a question.
Yeah.
In the homework, they always give the answer like at the ending of they give fraction all the time.
They leave
So
it as a
it
fraction?
confused me. Yeah,
Okay, instead of a decimal, you mean?
yeah. They say at the ending of the answer, they always
Okay.
give like a fraction. It's confusing me. Sometimes when I calculate, I
Yeah.
got differently.
Right, because
So I'm stuck in that one. I don't know.
Okay. Well, email it to me, okay?
Okay.
Email and we'll go through it. Now, the standard is this.
Mm-hmm.
If the if the question contains fractions, often you express your answer in a fraction. If the question contains decimals, you express your answer in a decimal. But you have to make sure it makes sense, because we would say, instead of saying 12.5 feet, we would often say 12.5 feet. But yeah, show me the example. There's that ask this instructor button, push that button and it'll send it right to me.
Okay, I will.
Okay. All right. I definitely want your questions answered. Any other
Oh.
questions?
I want to ask you, so we have to know all the formula by head?
Not this test. Okay.
Okay.
For this test, I will give you the formulas. There's only one formula, I think, and it's distance equals rate. Well, there might be two formulas.
Oh,
The only thing you would need to know is really the perimeter is the distance of the sides around, the total distance around. But if there are any formulas for this test, I'm going to give them to you. Okay.
okay.
Okay. Now the next test, we're going to have to know the formulas. Okay. All right. All right. So let's take a look. I'm trying to do that. There we go. And move on to the next example. Solving money problems. How many people would love all of their money problems solved? But here's
So
an
when-
example.
I have a question. So when we are doing this, like this kind of question in the test, we have to draw the table all the time, right? While
Nope.
answering.
That's a great question. You draw the table if it helps you.
Okay.
Draw the table if it helps you. You can do these problems without a table.
Okay. All right.
Okay. So let's go ahead and read this one. A collection of nickels and quarters has a total value of $14.60. If there are 28 more nickels than quarters, find the number of nickels and the number of quarters. Okay, well, what are we looking for? I am looking for the number of nickels and number of quarters. So I'm going to let quarters, that's going to equal a Q. And then nickels, I could let equal an N, but it says in here that there are 28 more nickels than quarters. So I'm going to express the nickels as the number of quarters plus 28, because there are 28 more nickels than quarters. Now find the number of nickels and the number of quarters. Okay, so we're going to go ahead and just organize some information in this chart. Now with nickels, the denomination of coins or bills, nickels, I know that nickels are 5 cents or 0.05 in value compared to $1. For quarters, 25 cents or 0.25 in value, parts of $1. Now the number of coins or bills. So for nickels, that's right here. I know that nickels are Q plus 28 because there are 28 more nickels than quarters. And I know for quarters, well, there's our Q. So if I'm going to look at the value of the coins, as an example, if I have 4 quarters, that's 4 times 25 cents, which gives me $1. So I have 4 quarters, I have 25 cents times Q quarters. The total value is going to be 0.25 times Q. That's going to give me the total value of my quarters. For my nickels are 0.05 times Q plus 28. That will give me the total value of nickels. Now we have to set up our equation. Well, I know that if I add the value of nickels plus the value of quarters, that's going to give me my total value of $14.60. So let's substitute from the chart what our value of nickels is. Well, my value of nickels is 0.05 times Q plus 28. My value of quarters is 0.25 times Q. And my total value is $14.60. For this example, I would like to clear my decimals because I have decimals everywhere. To do that, since I have 2 spots to the right of the decimal on all 3 of those terms, I'm going to multiply the top or the left side by 100, which means I have to multiply the right side by 100. So 100 will go towards this first term, and I have 5 times q plus 28. And then this 100 will be times the second term, which is 25q. On the right side, 100 times $14.60, I get 1,460. So notice that the decimals moved in each term, moved 2 spots to the right, and we cleared the decimals. Now I'm going to finish solving by clearing parentheses first. So we multiply that q through, we distribute it to each of the terms, 5q, and then 5 times 28 is 140. I'm going to write the rest of the word or the equation. Combine like terms. Well, what I can do is I can combine the 5q and the 25q into 30q. Next, I'm going to subtract 140 from both sides. So it cancels off of the left. And then on the right, I get 1,320. Checking my math looks good. Final step. I'm going to divide by 30 to get q alone. And q is equal to 44. So I will end up with 44 quarters, and then q plus 28 is 44 plus 28, or 72 nickels. All right, so I'm going to express my answer right here. There are 44 quarters and 700, or I'm sorry, not 700, 72 nickels. And our total value is 1460, and that's exactly what it equals if you were to check. Okay, let's do one more example, and then we're going to take a break. So Thomas Mason invested part of his $10,000 inheritance in a savings plan that pays 4% simple interest, and the rest in a certificate of deposit, or a COD, that pays 6% simple interest yearly. At the end of 1 year, the investments earn $520. Find the amount invested at each rate. Okay, well, this is simple interest right here. It says simple interest, and there is a formula for simple interest. It is interest equals principal, which is the amount you invest, times the rate, which is the percentage rate in decimal form, times time in years. All right, so interest, I is interest, the interest, P is the principal. Oh, erase that. R is the interest rate. And T is the time in years. Now the time in years, so if it was 2 years, T would be 2. If it was half a year, T would be 1/2. All right, so we are taking this $10,000 and we are putting it into two different accounts. And they want us to find the amount invested at each rate. So the amount that we put into each account. So if I want to show you something that if I have this $10,000 and I'm going to split it into, we'll put it into, I like thinking of bags of money. Okay, so the first one is at 4%. And then the second one is 6%. Now, if I invested, and this is just an example, so if I invested, let's say this X represents $3,000. At 4%, that would put $7,000 at 6%. And how we end up getting that is we take the total amount that we invested between the two accounts and we subtract the amount that we put at 4%. So if we invested $6,000 at 4%, that means we would do $10,000 minus $6,000 or $4,000 at 6%. So I'm going to use a chart again. Let's organize our information here. So we're going to have our 4% simple interest, which we have right here, I is equal to PRT. And we're going to have our 6% COD, which is also simple interest. It says here, 6 simple interest yearly. So X is going to be the amount invested at 4%. And 10,000 minus X in parentheses is the amount invested at 6%. So let's fill in the chart. So with 4%, so we're investing X amount. A 4% investment is 0.04. The time it says is in years, and it says 1 year. So our time is 1, and it's going to equal the amount of interest. So X times 4/100 times 1, in this case, is 0.04X. Now it's 6%. Since we put X is the amount we invested 4%, 10,000 minus X will be the amount invested at 6%. The interest rate at 6% is 0.06. It is still 1 year. And the interest is 0.06. We multiply across times principal times time, which is 1 year. All right, so when we look at this, our total interest. Okay, so the total interest will be right here. When we add the interest at 4% plus the interest at 6%, we find that we get a total interest of $520. And that is exactly what our equation will be. So we're going to take the interest at 4%. We add to it the interest at 6%, and I'm getting this information directly from the chart. And it's going to give us our total interest. Now I see the decimals and I want to clear the decimals. So I'm going to multiply the left side by 100 and the right side by 100. Now, multiplying by 100 will move the decimal point 2 spots. And on the right, it'll also move the decimal by 2 spots on the right. So instead of 520, we have 5,200. Right now we have a nice clean equation, and we're going to clear parentheses. Combine like terms. So we have minus 2x plus 60,000 is equal to 52,000. We're going to subtract 60,000 from both sides. That gives us our variables on the right or on the left and our constants on the right. Negative 2x is equal to negative 8,000. And then we will divide both sides by a 2. Moving up. And I get x is equal to 4,000. And 10,000 minus x would then have to be 6,000. Now we need to put this into words. X represented the amount invested at 4%. So we can say there was $4,000 invested at 4% and $6,000 invested at 6%. And that is our answer. We don't have questions about test 1. We can talk about the review as well. Then we'll just come back to 12.8 and get a little bit further to lighten our load on Thursday. All right, so going to 12.8, we're talking about solving linear equalities, which is really solving an extension of what we've already been doing. So for 2.8, I'm going to scroll to the top of the notes. I need to start preparing that way. There we go. Oh, there we go. Got to hide that. Solving linear inequalities. So a linear inequality in one variable, x, is defined as any relationship of the form ax plus b is less than 0, ax plus b is less than or equal to 0, ax plus b is greater than 0, or ax plus b is greater than or equal to 0, where a never equals 0, which means we always have a variable in the inequality. So we don't call these equations because there is no equal sign. We call them inequality because the two sides of these are never or very rarely equal, typically not equal. So the first thing I want to do is to graph each of the following inequalities on a number line. Okay, because it represents a zone of numbers, like as an example, I like the weather to be at least 60 degrees. Well, that means I'm happy for lots of different temperatures, right? 61 degrees, 70 degrees, 90 degrees. And so inequalities talk about really zones of numbers, okay, or a group of numbers. So the first thing that we have, and I want to talk about these number lines, is just the phrase of x is equal to 5. On the number line that I have, if I wanted to represent x was equal to 5, I would put a solid dot, not a circle, a solid dot, and that only represents that one solution of 5. Now the difference when we look at an inequality like we have in number 2, and we speak this, or we say it as x is greater than -1. Notice x cannot be -1. It has to be greater than -1. So what we're going to do is we're going to circle that -1. It's where we're going to start. And if x is greater than, well, look at the numbers on the number line. To the left, the values get smaller. To the right, the numbers are greater than -1, or they get bigger. So I'm going to express this as, I'm going to darken that line and then keep pointing, because the values can continue to get bigger and bigger and bigger and bigger, and they will all be greater than -1. Now, a way that the book uses, and sometimes my math lab can use this as a way to express the value at -1, is they sometimes use a curved parenthesis. Okay, so instead of the opened circle, the hole in the graph, they use a curved parenthesis, and we'll see why that is in a little bit. Now the next one speaks or says that x is less than or equal to a 7. Now here we have two things we say with this inequality. It's less than or equal to. So being equal to 7 is okay. So we're going to not put an open circle, but a filled in circle at 7. And then for x to be less than 7, then that's saying all the values less than 7, we would bring or draw this arrow to the left. And we have to have an arrow at the end, which means we continue to get smaller and smaller and smaller. So all of the values that I have under the squiggly line and so forth would be solutions to this inequality that x is less than 7. All of them. I could say 1 is true. It's part of the solution because it's less than or equal to 7. -8 is less than or equal to 7. 7 is less than or equal to 7 because I have the or equal to in there. Now for this, what the book or my math lab would show is that we could also do a square bracket and go. So the curved bracket means to not include. The square bracket means to include. So you will see sometimes notation of that form with putting these numbers on a number line. So number 4, x is less than -3. So we're going to find -3. We're going to put an open circle and x is less than. So we'll do our little squiggly line or just darken it to the left. So it's all the values less than a -3. We could also do the curved parenthesis and then do the arrow. And then for x is greater than or equal to 0, we'll put that closed dot on 0 and draw my line to the right because it's all values bigger than 0, including 0. And if we wanted to use the square brackets, we can do that because that square bracket means we're going to include the end, just like this solid dot says we include the end. And we draw the arrow where the values get bigger or to the right. Now we can also express values or on a number line, inequalities that have two parts. And these are called compound inequalities. So in a statement that involves more than one inequality is a compound inequality. Compound inequality. So when we look at an inequality like number 6, and it says -5 is less than x is less than 3. And one observation means x is all of the values between -5 and 3. Notice that the inequality signs are going in the same direction. They're both pointing to the left, which you have to have. But what this also means is that -5 is less than x and x is less than 3. So when the definition says that it involves more than one inequality, it is a compound inequality because we can break it up to these two smaller inequalities. Now, when we're going to graph it on the line, what we do, as long as the inequality signs point the same way, and it makes sense, because -5 is less than 3 as well, we're going to say, okay, well, -5 is less. Okay, so we don't include the -5. There's a hole there. It's less than x is less than 3. And so here's the 3. We put a hole there as well because it doesn't include, you don't have either is equal to with either of those signs. And then x is everything in the middle. Everything in the middle. So that would be the number line graph of -5 is less than x is less than 6. Now let's take a look at number 7. 1 is less than or equal to x is less than 3. So with this, we would have 1 is less than or equal to x and x is less than 3. Both have to be true. And when you look at the compound inequality, it just says x is all the values between these. Okay, so we're going to start with 1 is less than or equal to x. So here we are going to include the 1. We would include the 1. But we do not include the 3 because x is strictly less than 3. So we put a hole. And it would be everything in between. So we make sure we darken it. So that would mean x could be a 2, x could be a 1.1, x could be 2.9, x could be 1 here. So it's all of those possible values that we would have in between. Now I do want to say just real quick, because I was talking about the other type of notation. We could use in number 6, we could use the curve brackets and it's everything in between. And for number 7, we would do a square bracket on 1 and a curve bracket on 3, and it's everything in between. So you can use either type of notation. Now the last example that I want us to do here, and then we'll move on to our review, any questions we have about test 1, is I want us to look at number 8. Now a couple of things. We have a compound inequality. X is, or it says -2 and 5/10 is less than x, is less than or equal to 3 and 24/100 or 3.24. The inequalities point the same way. That's great. -2.5 is less than 3.24. That's great. But when you look at the number line, these are all integers, right? 1, 2, 3, -5, -6, -7. So what we're going to do here is we're going to just estimate where the points are in the label. So -2.5. I know that's going to be between, excuse me, it's going to be between -2 and -3. So this is the line right here, -2.5. -2.5 is less than x, so I have my hole there, is less than 3.24. Okay, so 3.24 is between 3 and 4. It's a little more. 3.24. It's a little more than 3. And then, but it's less than or equal to, so I'll put a solid dot here, but it's everything between, everything between. All right, so if the values aren't on the number line, make sure, approximate where they are and label them to finish the graph. And we want to write this in using the square brackets or the curve brackets. We don't include -2.5. So we would put a curved bracket there. We do want to include 3.24. So we put a square bracket and it would be everything in between. Everything. Okay. So are there any questions on inequalities, just graphing them on the number line, or graphing a compound inequality on the number line? All right. All right, so what we're going to do is we're going to transition to testing test 1, which is this Thursday. I've had one student has taken it, 2 students have taken it early actually. But then we'll test first thing when we get together on Thursday. I've sent out the test instructions and I'm just going to talk about it real quick. So the test, you're going to have your phone and D2L on your computer. The test is under assessments to view test, and then it'll say test 1. It'll open 5 minutes before the testing begins, before our time begins as a class. So what you're going to do, you have 60 minutes to finish the test. And then we're going to use a scanner either on your phone or at your home. And you'll scan the test and download it to, in the Dropbox under assignments, it says test 1 Dropbox. And you just load it and then you're done, okay? You can use a small calculator. Phones are never okay to use on calculators on any math test. Pencil, paper, you're gonna have your paper available to do the questions in order. What else? Formulas will be given. 11 algebraic questions, 3 study skills questions. Okay, so are there any questions on test 1 at this time? Any other things that I haven't thought about that you might want to know?
It's gonna be how many questions? 14, right?
14, yep.
It's gonna be 7 elementary algebra.
11
Uh-huh.
algebra
Uh-huh.
and 3 study skills.
3 study. Okay, that's good. Thank you.
Every question is worth 5 points. Okay, I try to weight my questions equally on the test. So it's a 70-point test, but it ends up being just part of your testing pool.
Okay, so yeah, if you have a scanner in your phone, you can just like scan it in your phone, and then you can put it in your like in your file, and then you can download it in the D2L, right? That one can be possible too.
Yes, that's exactly what you do. Yep. Okay. So practice scanning before you come. Zach, did you have a question?
I was just going to clarify the process. So the directions you posted on D2L, right?
Yep.
Okay. So everything we need to know should be on there. And then we're getting
Yes.
our questions from our phone on D2L while we're meeting like this on Zoom at like the same time.
Right. I would put D2L. So what it is, when you open the test, it's 2 images. Okay. Big snapshots. One of each page of the test. So
Okay.
on the test itself, when you look at it, there isn't any room to work. It's just the questions.
Right.
Then
And
you need to do the work on your paper in front of you. Does that help, Zach? And then
Yeah.
when you're done, those are the pages that you scanned me.
right. I was just
Pages.
clarifying all that.
Okay.
This one you allow?
Let me see. Yep, that one's good. That works.
That's one?
Yep.
Oh, okay.
Yes. Now, the last page that you're going to have to scan to me is a picture of your student ID. I prefer a student ID over a driver's license because of the, I don't want your driver's license number. Okay. I just want a scanned picture of your student ID for everybody, for my own record.
I don't have a student ID too.
Oh, well, could you send me a picture maybe of your license with a piece of paper over your
Yeah,
driver's number? Okay.
yeah.
I
No,
just want to make sure that you're protected. That's all.
Can I use my password thing, my password ID,
Your,
passport?
yeah. But I would, again, just passports are great. Just put a little paper over the information, like the number.
Okay.
Okay. I would like to see your name and your picture. Really what I need. Do you have a question, Wyatt?
Okay, so so what you prefer there, passport or driving license?
Either one.
And
Whatever's
where-
easiest for you. That's what
okay, and where I can get the ID?
the ID.
Yes, student ID.
Oh, so if you don't have to send me a number, I just need your name. I don't need your student. So have you been on campus to get a student ID?
No.
No, see. So you'd have to go to campus for that, and I don't know if they're actually offering that service. So just send me something that has your picture and name. Put a piece of paper over your personal information, and just
Okay,
use that.
and you was talking about the survey. People, they said they get email for survey, but I didn't get it, and I don't know because maybe I don't have student email address.
Oh, yes. Could you email me right after class?
Okay.
The problem is my math lab is really, it's blowing up email wise right now. And I'm having a difficult time. So the emails are sent to your school IDs. I'm sorry about that. And I can't even send an email through my math lab to tell you about it. So let's work through getting your school ID, your email information, okay?
Yeah.
Send me an email and we'll work through it together.
Okay, I'll stay after class.
Okay, perfect. Any other questions about test one? Any information about content on test one? Okay,
Oh, sorry. I was on homework. Are we able to do the correction?
on your homework, you can do, you can correct them as much as you want. Yep, you can, so if you missed 2 questions, you can go back and redo those 2 questions.
Oh, I don't know how.
Oh, you should be able to click on them. Again, let's work through that together, okay?
I have a question.
Yeah.
Like the test where we did when we write it in a paper, that's where we take the scanning pictures, right?
Yes,
Okay. Then the last thing we take the student ID picture and then send it to you again.
perfect. The last picture can be that. Yep,
Okay.
okay?
What is the scanner
How
program?
many pages do we need to scan?
It depends on how many pages you use to do your test.
Or you
Maybe-
can upload.
Maybe 3.
Yeah. Okay. Okay. I wanna make sure.
I think you could do it on 3 pages,
Mhm.
okay?
Okay. All right.
Erica, did you have a question?
Yes, this was on everything up to 2.5, right? That
Yes.
we've gone over? Okay,
Yep, through 2.5, so including 2.5.
including, yep.
Yep.
Okay,
Anybody else? All right, so is it okay? So if we have any more questions, feel free to email me. We can stay after class for a little bit. But if it's okay with you, I want to continue with 12.8. It'll lighten our load on Thursday. Can I get a thumbs up?
I just have a question for, like this is off topic about like the attendance. Do you actually take attendance when we click on live?
No.
No. Oh, okay.
No, I do view to make sure that students have at least been engaging online for 2 weeks. Because if you haven't done anything for 2 weeks on My Math Lab, and you then that is, it's a school policy. I think it's a MnSCU policy of no attendance for 2 weeks. It's called the last day of attendance. But I would contact you. Okay, but as long as you're active on My Math Lab, I'm here to help what you need. So Kelly and I are going to talk about scanning. Awesome.
I have one question that might be a little unrelated to this, but it's real quick.
Okay.
Our discussion posts, are those graded? Because I know some of my other classes, they do grade the discussion posts.
The discussion posts are, I read through them, but I have to finish the grading. So I did the reflection number 1. I have to grade. I'm going to look for I will let you know when it is a graded discussion, and we have just the first one from first day or from the first week.
Okay.
Other than that, the discussions that are open are just for you to post questions and answer questions from other students.
Okay. So if they're one that is going to be graded, it'll be posted on
Yeah,
D2.
I will warn you. Mhm,
Uh,
definitely.
okay. It won't be on My Math Lab though.
No, it's in your schedule.
Okay.
And I would include it in an email. I'm going to be doing a weekly agenda emails every Friday, so you know what we're going to be working on the next week.
Okay. Thank you.
Okay. Yep. All right. So we're going to go back and do more of 12.5, 12.8. Sorry, 12.8. Okay. Awesome. All right. So here we go. So we're going to continue talking about inequalities. And another type of notation that we have is interval notation. And it helps us to describe an inequality or a range of numbers in a concise manner. And so what I would like to do is a couple of things. I want us to write the interval notation, okay? We're going to graph what it means on the number line. And then I'm also going to write the inequality that it would mean. Okay, so we're going to put those 2 bits of information together. So with interval notation, we have the curve parenthesis, which we looked at actually when we were graphing the other ones, and it means you do not include that endpoint. We have a square bracket that you'll see in the next example, and that means we would include that endpoint. So we would include 6 here. And with these interval notation, we have infinity, which means it goes on forever in one direction to the right. It gets bigger and bigger and bigger. And you'll see in the second example, we have negative infinity, and that means it continues forever in the negative fashion. So for the first interval notation, we would have, and this is how we say it, the interval from -3 to infinity, not including -3, because it's a curved parenthesis. And so on the number line, I would put a circle at -3, and it goes to infinity. So I always draw these kind of, I try to start with from left to right, if I can. And so this would be to infinity. Another way is that we could do the curved bracket to infinity. Now this interval notation, thinking back to the inequalities that we graphed, we would say -3 is less than x. That's to write it in this fashion. Now I can flip this around because our inequalities, we often start with x when we say it, but we could also say here that x is greater than -3. I'm going to rewrite those a little bit to stay on the paper. So we can say that -3 is less than x, because x keeps going bigger, or x is greater than -3. Notice when I switch those two sides around, I switch the inequality sign as well. Now let's take a look at the interval, the next interval. And how I would say this is the interval from -infinity to 6, including 6, because that square bracket means I include 6. So I'm going to start from this lowest part, and I'm going to go all the way up to 6. I would include, I put a darkened dot on 6. And so to show that it's everything less than 6, I would make a line, darken it. I use,
Candace, I have a
yes,
question.
yes,
With the one that we're doing right now, the bracket is what indicates that it's the closed circle, right?
exactly. So the
Okay.
curve means we do not include it. The square means we do include it.
Sounds good. Thank you.
Yes, thank you for asking that, Kelly. Okay, now, again, when we have this square, and that's why the book will sometimes use the square bracket, because it mimics the interval notation. So again, the curve means we don't include it. It's everything but that in the interval. And the second one means we do include it. Just for a further example, for -3 and to infinity, we could include -2.9 because it's just bigger than -3 and it's everything bigger. We could include -2.99999 because still that's a little bit bigger. It's a hair bigger than -3, so that's in there. But -3 is not included because it's a curved parenthesis and we represent it by this hole in the graph. Okay, now let's take a look at this compound inequality. Now I know that's a compound inequality because this is the interval from -5 to 2. Now for those of you who have plotted points on a coordinate system, this looks a lot like an XY point, but it is an interval. So you need to look at the context in which it's being used. So here we have an interval from -5 to 2. And we would use an open circle on -5, an open circle on 2, and we'd represent it by everything in between, a darkened line, a squiggle. This shows it's everything in between. Now the numbers that would be included here would be like -4.99, -3, zeros in this interval. Anything that's even just a little bit less than 2, like 1.9, 1.999. And how we would use that with the other brackets is we could just use the curve brackets, which also represent not including those endpoints. Excuse me. Now we have infinitely many solutions or values in here. We can always find numbers between -5 and 2. It isn't just -4 or just -3, but it's all of the numbers between them as well. Now, how I would express this, and I want to go, we'll finish this one and want to go back up here and talk about how it's an inequality. For this interval, the interval from -5 to 2, not including 5 and not including 2, not including -5 and not including 2, we would write that as -5 is less than x is less than 2. The interval above, that -infinity to 6, including 6, we would say that x is less than or equal to 6. So we do include the 6 because it can be in there, but x is less than or equal to 6. Let's move on to the next interval. This interval is the closed interval. Okay, up here we call that open. It's open, which means you don't include the endpoints. Closed means you do include it. So the interval from 4 to 9, including 4 and including 9. So here you would put a dot on 4 and we put a dot on 9, and it's everything in between. So if we're going to use the square brackets, we'd use square brackets on 4, square brackets on 9, and show everything in between. Now, the less than or equal sign, greater than or equal sign, those go with the square brackets. When it is strictly less than or greater than, those go with the curve brackets. So here, when I look at, we include 4 and we include 9, my inequality, my compound inequality would be 4 is less than or equal to x is less than or equal to 9. And the last one on this page, we have the interval from 5 to infinity, including 5, because of the square bracket. So we're going to put a solid dot on 5, and it goes to infinity. So we would just draw that to the right and point, and that arrow means it goes on forever. And that's what that infinity means also, it goes on forever. We can also write this as square bracket from 5. I'm sorry, we're just drawing the number line here. We can put a square bracket at 5 and also draw an arrow. And how we would write this as an inequality is I'm going to put a 5 here. 5 is less than x, which means x gets bigger and bigger and bigger and bigger. Or we can write this as x is greater than 5. Now these two inequalities, when I'm using the inequality notation, are the same. Notice that when I change the positions of 5 and x, when I flip them around, I also flip around that inequality sign. Now, it does take some practice to convert between inequalities and the notation and the interval notation. They have different uses. And so we will just continue to practice with them when we're doing inequalities and in word problems moving forward. So are there any questions? Are there any questions about the interval notation, about graphing an inequality on a number line? Okay, well then let's continue. Let's continue. So what we can do with these inequalities is we can, I'm trying to move that, there we go. We can have inequalities, linear inequalities in one variable, and we can solve them and we can write the answer. So with the addition and subtraction properties of inequality, notice this. So we're going to say let A, B, and C be real numbers. Okay, they're actual numbers. With the addition property of inequality, if A is less than B, then A plus C is less than B plus C. Now this property is similar to the multiplication property of equality. I'm sorry, the addition property of equality, but it's the addition property of inequality. So we keep the sign as an inequality. And similarly, subtraction property of inequality, if A is less than B, then A minus C is less than B minus C. And I could also say similar, if A is greater than B, then A plus C is greater than B plus C. And I can also say that if A is greater than B, then A minus C is greater than B minus C. Okay, and we can say that. So what we're going to do is we're going to use the addition and subtraction properties of inequality to solve our inequalities. And we want to get, we would use properties to, we could, the addition and subtraction properties to get our variables on one side and our constants on the other. So for the first example, I want us to solve the linear inequality, and it is negative 2p plus 5 is less than negative 3p plus 6. So I know that if I add the same thing to both sides, and I'm going to start with by adding this 3p, that my equation or my inequality remains true. So to negative 2p plus 3p gives me p plus 5 is going to be less than negative 3p plus 3p, that cancels, plus 6. And then to get p completely alone, I'm going to subtract 5 from both sides. Cancels off of the left, and I have p is less than 1. Now let's practice writing, this is a great answer, p is less than 1, but let's practice writing this in interval notation. To do that, what I like to do is first put it on the number line. Okay, so I'm going to write a little number line. Doesn't have to have a lot of values on it. And I'm going to graph the inequality, p is less than 1. So if p is less than 1, I don't include the 1. And it'd be all of the values to the left of p. All of those values. Now to write this in interval notation, okay, I always, it's going to go to the left forever, and that's negative infinity. So I would do a curved parenthesis on negative infinity, and then it continues, because that's what that arrow means, and it continues all the way to 1. And then I do not include 1, so I put that curved parenthesis. So sometimes they will say, solve this inequality, expressing your answer in interval notation. And that is exactly what we did. I recommend using the number line to get to the interval notation. It doesn't take long, and it just really shows you how it needs to be written. Interval notation always needs to go smallest to biggest from left to right, and it mimics the number line. Any questions? Okay, let's go on to number 2. Now, example number 2 is 2y. We're supposed to solve the linear inequality. 2y minus 5 is greater than or equal to y minus 11. All right, so I know that if I subtract something, the same thing from both sides, it keeps the same inequality sign. So I'm going to subtract the y from the right and from the left. Notice it cancels off the right. And on the left, we have 2y minus y. So we have y minus 5 is greater than or equal to negative 11. And then to get y completely alone, I'm going to add 5 to both sides. Cancels off with the left. And I have y is greater than or equal to negative 6. This is y is greater than or equal to negative 6. So I'm going to put a dark circle at negative 6. And it's greater than, which means the numbers get bigger, and I go to the right. Okay, so if you look at it, it's going to be everything over here to the right. To write this in interval notation, since it starts at negative 6, we go from left to right, I'm going to put a square bracket at negative 6. But then it continues forever to the right. And so it goes to infinity, and curved parentheses are always on infinity. They're always on infinity. Okay. Any questions? All right, so the last piece of information that we're going to talk about from these notes, and we can do more examples if we want on Thursday. I'll be ready to continue if anybody wants to continue after the test with just more examples, is we're going to talk about the multiplication and division properties of inequality. So we're going to let A, B, and C be real numbers. If C is positive, okay, so it's very important that C is positive and A is less than B, then A times C is less than B times C, or A divided by C is less than B divided by C. Now this holds true that if A is greater than B, then A times C is greater than B times C, or A divided by C is greater than B divided by C. So what that means is if you multiply or divide by a positive number, then you do not change the inequality sign. But if C is negative and A is less than B, then A times C is going to be greater than B times C. Notice the flip in the sign. If you multiply by a negative number, you have to flip the sign. And A divided by C is greater than B divided by C. Again, you have to flip the sign. So the second statement indicates that if both sides of an inequality are multiplied or divided by a negative quantity, the inequality must be reversed. So I want to take a look at a few examples of how this would work. With example number 1, we're supposed to solve the inequality. Negative 5x minus 3 is less than or equal to 12. The first thing I'm going to do is I'm going to add 3 to get the variable alone on one side. So 12 plus 3 is 15. Then I'm going to divide by that negative 5. Now, when I divide by a negative 5, I have to go from less than or equal to greater than or equal. I have to reverse the inequality sign. And then we just work and we cancel those negative 5s on the left. 15 divided by a negative 5 is a negative 3. And we say that x has to be greater than or equal to negative 3. Okay, I'm going to write this in interval notation as well. So here's my 0, 1, negative 2, greater than or equal to. I'm going to put a dot on that negative 3, and it's everything to the right. So what that means here with this solution is that any value in this squiggly line, negative 2, negative 1, 1/2, 100, those values of x are going to keep this original inequality true. They will keep it true. And how we would express this in interval notation, starting from left to right, is we start at negative 3. That's a square bracket because we include negative 3. And then we go forever to the right. And that would be our infinity with a curved bracket. So this would be the inequality notation, and this would be the interval notation. But any number bigger than negative 3, including negative 3, is a solution. So the last example we have for our day. Solve the linear inequality. 2p minus 3 is less than 5p plus 15.